Lesson 7, I will use the area model and multiplication to show the equivalence of two fractions. So in the last 3 lessons, we've been talking about finding equivalent fractions using the area model. And today we're going to continue that. The only thing is we're going to add on how you can use multiplication to show the equivalence. So it's great to have a model, but after a while it gets kind of tiring to always have to draw that model to find equivalence. So today we're going to look at what we've learned about the model and how we can use that to use multiplication to find equivalent fractions. All right, so I want you to go ahead and write your name at the top, and then let's take a look at the directions. Each rectangle represents one hoe, so that's why none of these area models are labeled one hoe, because it tells us right here every one of these is equal to one hoe, so you don't have to label them. It says the shaded unit fractions have been decomposed into smaller units. Express the equivalent fractions in a number sentence using multiplication. The first one has been done for you. So we can tell by this area model that originally this was 1 out of 2. And they decomposed it with one horizontal line, so now it is 2 out of 4. And you can see right here how they used multiplication to determine this. They multiplied the numerator and the denominator by 2. It's really important that you notice that every time they use multiplication, they're multiplying the numerator and denominator by the same number. If you don't do that, you're not going to have an equivalent fraction. All right, so let's talk about B for just a second. So first of all, take a look at this area model and determine what was the original fraction. Look at it without the dotted lines. So hopefully you were able to determine that this began as 1/2. So let's go ahead and write 1/2. All right, so now what could we multiply the numerator and the denominator by to get this equivalent fraction? Well, it went from 1 out of 2 to 3 out of 6. So we're going to multiply the numerator and the denominator by 3, which gives us the new fraction, which is 3/6. All right, let's take a look at C. So again, it began as 1/2. Why don't you go ahead and after you write 1/2, why don't you go ahead and pause the video and just see if you can try to write this multiplication sentence by yourself. If you get stuck, you can always press play and come back and do it with me. Okay, so we had 1 out of 2, and now I have 4 out of 8. So if I take 1 and multiply it times 4, and I take 2 and multiply it times 4, I have my new equivalent fraction, which is 4/8. Okay? If you didn't try to do C by yourself, I want you to try to do D by yourself, and go ahead and pause this video and see if you can write the whole multiplication sentence by yourself. All right, so we're going to start here with 1/2, and I'm going to just go ahead and write my 1/2 here, and I know I'm going to multiply the numerator and the denominator by the same number. So I've got 1, 2, 3, 4, 5 out of 10. So I'm going to multiply both parts of this fraction times 5, and now I get my equivalent fraction of 5/10. All right, let's look at number 2. So this time we're going to do a little bit more by ourselves. We have to decompose it ourselves. So it says decompose the shaded fractions into smaller units using the area models. Express the equivalent fractions in a number sentence using multiplication. So I want you to go ahead and do A and B with me, because you could do it differently than I did, and then we wouldn't be sure that you understand. So let's at least do the first 2 together, and then if you want to try C and D by yourself, that would be great. Okay, so let's start off a little simple. We have 1 out of 4, so I'm going to go ahead and put 1/4, and let's just decompose this one time with one horizontal line. So I took the numerator and the denominator, and I went from 1 out of 4 to 2 out of 8. So I doubled the number. So I'm going to multiply the numerator and the denominator by 2, and I'm going to have my new fraction, which is 2/8. Okay, so this time I have 1 out of 5. Let's go ahead and let's triple the number by drawing 2 horizontal lines. So if I tripled the number of parts, instead of multiplying by 2, I'm going to multiply times 3. Okay, so now instead of having 1 out of 5, I have 3 out of 15. So I'll multiply the numerator and the denominator by 3, and I have my new fraction, which is 3/15. So if you're feeling pretty confident about this, why don't you go ahead and try to do C by yourself. Now just keep in mind that you may decompose yours differently than me, and that's okay. Just remember that you must multiply the numerator and the denominator by the same number. If you did it by yourself and you're not sure if you did it right, you can always bring it to me and I'll be glad to tell you if it's correct. All right, so I have 1 out of 1, 2, 3, 4, 5, 6. So I have 1/6. And I'm thinking I'm going to decompose this with two horizontal lines like this. So I'm tripling the number of parts. So if I triple it, then I'm going to multiply the numerator and the denominator by 3, just like I did in B. So let's see if this gives me the right number. So I have 3 over 18. So I have 3, 6, 9, 12, 15, 18. So that is correct. I have 3 out of 18. Okay, so let's look at D. I have 1, 2, 3, 4, 5, 6, 7. So I have 1 out of 7. So I think this time, instead of doing just 1 or 2 parts, I'm going to actually divide this into, divide this into 4 parts. So I'm going to draw 3 horizontal lines. So this time I'm going to multiply my numerator and my denominator by 4. All right, so I've got 1 over 7. I'm going to multiply both of these times 4, and that gives me 4/28. So let's look and see if that's exactly what I have here. So I have 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7. I have 7 groups of 4, so that would be 28. So 4/28. So keep in mind that if you decomposed yours into a different number, then your multiplication sentences are going to be different than mine. But the most important part here is to make sure that you multiplied your numerator and your denominator by the same number. Okay, so let's look at E. So what happened to the size of the fractional units when you decompose them? So let's go back here to dual page view so we can take a look. So what happened to the number of units? So I went from 7 to 28. I went from 5 to 15, I went from 4 to 8, and I went from 6 to 18. So what happened to the number of fractional units every single time? What do you think? Every single time they increased, right? So let's go ahead and write a sentence. So the fractional units increased. They got larger every single time. What happened to the total of number of units in the whole when you decompose the fraction? Well, the numerator and the denominator increased every single time. So it's going to be the same answer here. The total number of units increased too. Whenever you decomposed, you broke it into smaller parts and you got more parts. So both the numerator and the denominator increased every single time that we decomposed the fraction. Now it says draw 3 different area models to represent 1/3 by shading. So let's just do that first, okay? So we've got A, B, and C here. I'm going to make this a little bit smaller so that we can see the whole page. And we're going to draw 3 different, ooh, that's too small. Let's draw 3 different sets of 1/3, okay? So I want you to do that too. You can go ahead and pause the video while you do that. I'm just going to draw 1/3 3 times and shade 1 out of 3. I'm actually going to pause my video so you don't have to watch me do that. Okay, so now you can see that I have drawn 3 different models, area models representing 1/3. Now it says decompose the shaded fraction into 6, 9ths, and 12ths. So we're going to have to come back up here and let's take a look at this. So I have to divide or decompose the first one into 6s. So that means I'm going to go from 1 out of 3 to 2 out of 6. So I'm just going to draw 1 horizontal line here. And then for B, it says to make this one into 9ths. So if I'm going to go from 1 out of 3 to 3 out of 9, I've got to make this, decompose this into 3 parts. And then 12ths, how many parts do you think that would be? Let's see if you and I agree. 4 parts, right? Okay, now let's see what it wants us to do next. Then it says use multiplication to show how each fraction is equivalent to 1/3. Okay, so for part A, let's do this one together. So we have we started out with 1/3, and we have to multiply the numerator and the denominator by the same number. So I went from 1 out of 3 to 2 out of 6. So I doubled the parts. I'm going to multiply the numerator and the denominator by 2. And my new fraction is 2 6s. All right, so if you feel like you know how to do B, go ahead and pause the video and do it by yourself. The worst thing that happens is you don't do it right and you just have to erase and fix it. But who knows, you might get it correct. So go ahead and stop the video and try to do this by yourself. Okay, so hopefully you and I are going to agree here. We're going to start with 1/3, and I took each of these parts and I tripled them. So that's why I'm going to multiply the numerator and the denominator by 3, and then I get the equivalent fraction of 3/9. Okay, try to do this one by yourself. So go ahead and pause the video, try to do it by yourself, and then come back. Okay, so we still have the same beginning fraction. It was still 1/3, but this time we quadrupled the parts. We went from 1 out of 3 to 4 out of 12. So we took the numerator times 4, and we took the denominator times 4, which gives us our new equivalent fraction, which is 4/12. Okay, so today we talked about how you can use an area model. Here's our area model, and we also talked about how you can use multiplication to find equivalent fractions. When you're decomposing, you're not changing the fraction, you're just making it into more parts. So whatever you're doing to the numerator, you're also doing to the denominator. So the most important part to remember here is that whatever you multiply times the numerator and the denominator, that it is the exact same number. And we will continue this in lesson 8.